Galactic cosmic rays and propulsion systems, GCR or galactic cosmic rays, are present in the universe and in the form of energetic high-speed particles that can interact with matter except the dark matter, energy regions. Their origins and their energy intensity is subject of the observer local position, velocity and orientation, interstellar medium conditions, and the local magnetic field parameters as magnetic density, magnetic pressure and temperature, are local. ISM, interstellar medium as a field concept boundary layer is related with the Sun 11 periodic activity. The heliopause is expanded in solar maximum and it is contracted in solar minimum. We cannot estimate with desired precision materials behavior for interstellar spaceship structures, while we are sitting inside the protection blanket region of the Sun, avoiding exposures from the dust micrograins of iron and silica and heavy particles. It is difficult to simulate these conditions on Earth, especially for the materials maturity cycles testing. However, it is possible. The creation of a probe non-manned mission for interstellar travel research, with the following minimum characteristics. The first mission to be on the heliopause. 250 astronomical units minimum, 500 astronomical units desired. Reach 250 astronomical units within 20 years from launch. 15 to 20 astronomical units per year target velocity. While the research to this field is realistic, with presented technologies, there are several considerations for Hall thrusters, photonic propulsion, chemical propulsion and antimatter propulsion. Hall thrusters are still sensitive to wall operational erosion, especially around cathode and for long-duration operations. There are several technical implications concerning their operational condition under the scope of passing through molecular dense clouds with high velocities, suggesting that they could not perform as expected and as a primary propulsion system force, especially for planetary landing configurations. Sail photonic propulsion could have hard times during and outside the boat termination region. This estimation holds under current structural configurations that cannot hold sized payloads for critical deep space research missions. Chemical propulsion cannot provide adequate speed to compensate long travel distances, neither is adequate to confront proper maneuvering near relativistic speeds. Antimatter propulsion, 10 mg of antimatter can produce 120 tons of conventional rocket fuel. To reach Alpha Centauri, we need 100 to 1000 tons antimatter. It is not necessary to be stored or carried at once, it could be rather produced during space travel. Again, this energy potential is not fully optimized for speed. Also, the large size of radiators is still a consideration for vibration issues at high velocities, affecting the structural safety of the mission. MVML research. The GCR abundance, their intensity and their directivity, could generate several research concepts as potential energy source used during space travel and for propulsion purposes, for interstellar and stellar missions. Augmented projectiles concepts for surfaces propulsion, starships propulsion substrates concepts can revolutionize the space travel propulsion systems for deep space manned missions with increased surface sizes, opening the era of colonization space travel systems. Future research on these space travel structures will require also energy source interactions that should react within the spaceship. The first generation of these particular new propulsion concepts will operate near the sea velocities.